Here are a few examples on simplifying exponential expressions. I'm going to use this set of steps over here. I'm going to start by looking for zero exponents. Anything raised to the zero is going to turn into a 1. It's just going to blend in with the wallpaper there. I'm then going to look for power rule applications where I have an exponent outside of parentheses, and then I can kind of distribute him in. I'm going to take care of negative exponents by having some term in a numerator go to a denominator, or vice versa. I'm going to combine like bases using the multiplication rule or the quotient rule. And the last thing that we're going to look for is simplifying any numbers that might have an exponent, because you don't want to leave numbers with exponents on them. That's not fully simplified. This first example, I can see right off the bat that I have an a raised to the 0. That is going to turn into a 1. Anything raised to the 0 becomes a 1, and 8 times 1 is still just 8. So that a to the 0, I tell my students just to pretend like that guy is blending in with the wallpaper. He just goes away because it's just a 1. So this is what we're left with. The next thing we're going to do is take care of this exponent outside of the parentheses. We are going to then apply him to each of these guys right here. If you were going to expand out this guy, that would help you understand why the power rule is applicable here. What we end up getting is 8. Let's be consistent with colors. I get 8 squared, so that 2 has come down and now sits on top of the 8. I get b to the negative 3 times 2, and I get c to the 5 times 2. Some of you are just going to do these little guys in your head. So this will be 8 squared, b to the negative 6, c to the 10. Remember, c to the 10 came from having 5 c's times 5 more c's. Then I want to take care of my negative exponent. When I have a negative exponent, that actually means I'm doing a division problem. So I have 8 squared, 1 over b to the 6, c to the 10th power. Now I can smush all these guys together if I remember that this is really just 8 squared over 1, c to the 10th over 1. And so I have 8 squared, c to the 10th, all over b to the 6. The last thing I need to think about, well, I don't need to combine any like bases because none of these guys are like bases. I have an 8, a c, and a b. I don't have any like bases, so I don't have to worry about that. Now the last step is simplifying those numbers with the exponents. So 8 to the 2nd power, that's going to be 64 c to the 10th over b to the 6th power. That is now fully simplified. There are no zero exponents. There are no negative exponents. There's no numbers that have exponents on them. All like bases are taken care of. So that is a fully simplified expression. Let's look at another example. This looks a little scarier, but once we clean it up, it won't be too bad. I see right off the bat, I have a 0 exponent around both of these guys. So this whole kit and caboodle right here in the middle, that's going to go to 0. Or excuse me, go to 1. So that's going to just be 1 times everything else. So 1's going to blend in with the wallpaper. So I write out my math again, and I can leave out that part. And now we're looking a little cleaner. The next thing I'm going to take care of is the power rule right here. So this 3 is going to come down to each of these guys right here. And I'm going to get 5 to the 3rd power, y to the 3rd power, all over y to the negative 1 times 3 is negative 3. I now want to take care of negative exponents. So this guy right here needs to come up to the numerator. What we end up getting is 5 to the 3rd power, y to the 3 times another y to the 3. if you're confused why this guy came up on the side here, if I write out my math like this, this is going to be over, instead of y to the negative 3, it's over the fraction. Well, that guy can turn into 5 to the 3, y to the third, divided by a fraction. When you divide by a fraction, you can write that as times the reciprocal, like that. So we have 5 to the 3, y to the 3 times that. These guys are just over 1. Go straight across, and we just get these guys in the numerator, which is what we have over here. Next, I need to combine like bases, and I have like bases, y and y. So if I have 3 y's times 3 more y's, I have a total of 6 y's. And the last step is I need to take care of any number with an exponent. Fully simplify him. So 5 times 5 times 5 is 125. Then we have times y to the 6, and there's my final answer.